Okay, so today we're going to look at experimental probability. We've looked at theoretical probability, and you'll recall that the theoretical probability is the number of favourable outcomes, what you're looking for, divided by the total number of possible outcomes. There's also this experimental probability, which relates to results from experiments. It's sometimes called estimated probability or relative frequency. So look out for those terms in exam questions as well. Just like theoretical probability, it can have a value from 0 to 1 or 0 to 100%. It can be a fraction, a decimal, or a percentage. If we look at how it's found by repeating an experiment over and over again and looking at the outcomes. And it's calculated by the number of times the event occurs divided by the total number of trials. So a coin in this case is tossed 10 times. They've got 7 heads and 3 tails. So the experimental probability of a head is 7 over 10 and a tail is 3 over 10. But you're probably thinking that's not what I'd expect. I would expect there to be probability of a half for both of them. 1 head over a head or a tail. 1 tail over a head or a tail. I've conducted a little experiment. I'm going to use the results to check if a dice from a board game is biased. Is it more likely to come up on a particular number than any other number? I chose the number 6. I'm going to check that the experimental probability for the dice is the same as the theoretical probability. And I'm going to look at the number of times I roll a 6. So here's my results, my trial numbers. Here's the result. Trial number, result. In summary, after 12 throws, there was 1 result that was a 6. After 24 throws, there were 3 results that were a 6. After 36, I had 6. And after 48, there were 8. I calculated the experimental probability and look at how it changed after the increasing number of throws. So 1 out of 12 gives me 0.083 recurring. 3 out of 24 gives me 0.125. And then we see that 36 and 48 give me exactly the same value. Can't really see it from the numbers. So here it is in graphical form. But that still doesn't show me how it's relating to the theoretical probability. If I draw a line in that shows me the theoretical probability, you can see that as the number of throws increase, I'm getting closer and closer to it until I have reached that theoretical probability. It indicates that my dice wasn't biased, and the more trials I do in an experiment, the more accurate the results are. If I looked back down here, I would be miles out in terms of probability. So the more you do, more trials, the more accurate.